Hello, everybody. So today we're going to continue with lesson 7.7, area and mixed numbers. Our essential question is, how can you use a unit tile to find the area of a rectangle with fractional side lengths? We are on page 333 of the 5th grade Go Math textbook. So let's look at the investigate problem. You can use square tiles with side lengths that are unit fractions to find the area of a rectangle. Lee wants to cover the rectangular floor of her closet with tile. The floor is 2.5 feet by 3.5 feet. She wants to use the fewest tiles possible, and she doesn't want to cut any tiles. So the tiles come in three sizes. We can have a 1 foot by 1 foot. We can buy 1/2 by 1/2, or we can buy 1/4 by 1/4 foot. Well, if we just looked at the areas of these, okay, and we focus on just the fractional part of the 1/2 by 1/2. Well, 1/2 by 1/2 is 1/4, right? So if I tried to cover that fractional part of the floor, let's say there were fourth size pieces, the 1 by 1 here would be 1 times 1 is the area. That's going to be way too big. I can't cover a fourth with a 1 without cutting it. It's going to overlap. Now 1/2 times 1/2, well, that is what I want, right? I want 1/4 size pieces. And then 1/4 times 1/4, I'd get 1/16. Well, I could combine 1/16 to get 1/4, right? If we compare 1/4 to 1/16, what can I multiply the 4 by to get 16ths? I can multiply it by 4, right? So it would take 4 1/4 tiles to equal 1/16. I'm sorry, I misspoke there. If I had 4/16, in other words, 1/16 plus 1/16 plus 1/16 plus 1/16, I would have 4/16, and that is equal to 1/4. So I would need 4 of these 1/16 tiles to equal 1 of the 1/4 area tiles. Okay, so if I take 4 of these, that would equal 1 of those. But it says here she wants to use the fewest tiles. So the best one to use is the 1/2 by 1/2. All right. So if we take a half by, that's what she should use, a 1/2 foot by 1/2 foot. If we take the 1 by 1, it's going to be too large, and she'll need to make cuts. She doesn't want to make cuts. The 1/4 by 1/4, which would be 1/16, we know will work, but it's going to take us four times as many as the 1/2 by 1/2. Because for every 1/2 by 1/2, I need 4 of the 1/4 by 1/4 to equal the same area. And she wants to use the fewest tiles possible. So now, on the grid, let each square represent the dimensions of the tile you chose. Then draw a diagram on the floor. Draw a diagram of the floor. So we're saying that each of these, if we look at one side, just this side is going to be a half, and that's going to be a half. So the area of every square is going to be 1/4. Okay, so on. All right. So how many of these 1/4 does she need? 1/2 does she need? So let's look at 2.5. How many halves are in 2.5? Well, in every one whole, there would be 2 halves. 2 halves is equal to 1. So 2 halves plus 2 halves would equal 2, right? 1 plus 1 plus the leftover half. So we'd have 5 1/2 tiles. And then if we look at 3.5, it's basically the same thing, 2 over 2 over 2. So we have 2 halves plus 2 halves plus 2 halves plus the extra half. So we have 7 halves. So 5 halves by 7 halves. So we can go down 5 and across 7. Okay, so the 5 halves tells us that there's 5 1/2 tiles this way, and the 7 halves tells us that there's 7 halves this way. Well, how many of these 1/2 by 1/2 square tiles do we have then? We have 5 times 7, or 35 squares. There are 35 squares in here, and each square is 1/2 by 1/2, which equals 1/4. 1 times 1 is 1, 2 times 2 is 4. So since one square on your diagram represents an area of 1/4, then that area is represented by 35 squares is 35 times 1/4. 35 times 1/4. We can rewrite 35 as 35 over 1, and 1/4 would just be written 1/4. Multiply the numerators, we get 35, and the denominators, 1 times 4 is 4. So we'd get 35/4 square feet. Or we can change it into a mixed number by dividing 35 by 4. And 4 times 8 is 32. Subtract, we get 3. So 8 and 3/4 square feet. So she needs 35 1/2 by 1/2 foot tiles. All right, number 1. Using the formula for area, write a multiplication expression that could be used to find the area of the floor. Well, the floor was 2.5 by 3.5. So that would be the expression, length times width, right? So we can rewrite the expression with fractions greater than 1 and calculate the area. So how many did we say was in 2.5? We said 5 halves, right? Because every whole number has 2 halves. So 2 times 2 is 4. There would be 4 halves in 2 wholes, plus the extra one, so 5 halves. 3.5 would have 3 sets of 2 halves. So I can rewrite the 3 whole numbers as 6 halves plus the extra 1 half. We'd have 7 halves. Well, what is that? Well, 5 times 7 over 2 times 2, I'd get 35 fourths. Is that the same as what we found with our model? Yes. How many 1/4 by 1/4 foot tiles would Sonia need to cover one 1/2 by 1/2 foot tile? Well, we said that 1/4 times 1/4 is 1/16. So how many 1/16 does it take to equal 1/4? And we already said that if we multiplied 1/16 by 4, we get 4/16, which is the same as 1/4. So we would need 4 tiles. So 4. How could you find the number of 1/4 by 1/4 foot tiles needed to cover the same closet area? Well, if it's going to take us 4 tiles to equal just one of the 1/2 by 1/2, I'm just going to multiply the 35 1/2 by 1/2 foot tiles by 4. So that would be 35 times 4 would be 140 tiles. Okay. All right. Another way we can do it. So sometimes it's easier to multiply mixed numbers if you break them apart into whole numbers and fractions. And so we have an area model that's 1 3/5 by 2 3/4. And we're going to rewrite each mixed number as the sum of a whole number and a fraction. Okay, so 1 3/5. Basically, it tells us what that means. It means 1 plus 3/5. And 2 3/4 means 2 plus 3/4. So we can draw an area model to show the original multiplication problem. The original multiplication problem is 1 3/5 by 2 3/4. So here, I want the fractional parts, the sides, to be the same. Fifths and fourths are a little complicated to think about, so I want to turn these into 20ths. So 1 3/5 times 4/4 equals 1 12 20ths. And 2 3/4 I would multiply by 5/5 to get 2 15 20ths. So basically we're multiplying 1 12 20ths by 2 15 20ths. So how many 20ths do we have in our drawing? We have 20 20ths plus 12 is 32 20ths times how many 20ths are in two holes? 20 20ths plus 20 20ths, so this is 40 20ths, plus 15 is 55 20ths. So basically, if we draw the model now, each of our squares in here would be 1/20th times 1/20th, or 1/400ths. Okay. I have 32 this way, and I have 55 this way. All right, now draw dashed lines and label each section to show how you broke apart the numbers in step 1. So that's what it would be if we're doing it the other way. So now let's take it and instead just write it as 1 3/5 times 2 3/4. Okay, so what did we do on this one? All we're using the mixed numbers. We're just breaking them apart. And so we're going to do 1 times 2. 1 times 2 is 2. And we're going to do 1 times 3/4, which is 3/4. Okay, so far that seems a little easier than what we were doing here. Now we go 3/5 times 2, which is 6/5. And we finish by multiplying 3/5 times 3/4, which is 9/20. Okay, now all we have to do is add the area of each of the smaller sections. So we have one that's 2, we have one that's 6/5, we have one that's 3/4, and we have one that's 9/20. All right, well, let's find common denominators. Okay, and I recognize that 3/4 can become 20ths by multiplying by 5. So 15/20, and I notice that I can multiply fifths by 4 to get 20ths. All right, so now we have common denominator. Now we can just add them up. And 25 plus 15 is 39, plus 9 more is 48. 48/20 plus the 2. Okay, so the 48/20 were these three partial products and plus 2. So I could leave my answer that and just say it's 2 48/20, but I can simplify that. So 48 divided by 20 is 2 8/20. So 2 8/20 plus 2 is 4 8/20. We can reduce the 8 by a factor of 4 and the 20 by 4. So we get 4 2/5. All right, let's keep going. All right, use the grid to find the area. Let each square represent 1/3 by 1/3. So if we do each square is 1/3 by 1/3, we'd say the area is 1/9. So each of these squares will be 1/9. How many squares cover the diagram? Well, how many 1/3s are in this one? 1 2/3 is the same as 3/3 plus 2/3. So 5/3, and 1 1/3 is the same as 4/3. So we have 5/3 times 4/3. So we can go down 5 and across 4. So we have a 5 by 4, which is 20 squares. And each of the squares will be 1/9, because 1/3 times 1/3 is 1/9. So what's the area? The area is 20 times 1/9, which is 20 times 1 over 1 times 9. So 20/9. We can simplify that by turning it back into a mixed number with a remainder of 2. So 2 2/9. Okay. 2 2/9 square meters. Use the grid to find the area and let each square represent 1/4 by 1/4. So if it's 1/4 by 1/4, that means each square is going to be 1/16 square foot. So each of the squares in this model will be 1/16 of a square foot. All right, so how many fourths are in 1 3/4? Well, there's 4/4 in this whole number, plus the extra 3/4. So there's 7/4. 1 3/4 is the same as 7/4. And 1 2/4 is the same as 4/4 plus 2/4, or 6/4. So we can go 2, 3, 4, 5, 6, 7 by 6. Okay. So we have 42 squares times 1/16. The area of each square is 1/16 because it's 1/4 times 1/4. So 42/16, which we can reduce by dividing by 42 by 16. I can take 2/16 from 42 with a remainder of 10. So 2 and 10/16, and we can reduce 10/16 by dividing by 2, and we'd wind up with 2 and 5/8. Okay. Number 3, 1 1/4 times 1 1/2. So I want to change the half pieces into fourths. So 1 1/2 is the same as 1 2/4. So 1 1/4 equals 5/4. There's 4/4 in 1, and the extra 1/4, 5/4. And 1 2/4 is equal to 4/4 plus 2/4, or 6/4. So we're multiplying 5/4 times 6/4. So 5 by 6. All right, and each of the squares again is 1/4 by 1/4, which is 1/16. So 30 times 1/16, which is 30/16. So 30/16, or reduce 1 with a remainder of 14. 1 14/16 I can divide by 2, and I'd wind up with 1 7/8. So these lines we need to fill in. We can say 42/16, or 2 5/8 square feet. And this one was 30/16, or 1 7/8. All right, number 4. Use an area model to solve. We have 1 3/4 times 2 1/2. 1 3/4 times 2 1/2. So let's make the halves into fourths. Multiply 2 1/2 by 2 over 2. And so we'd have 1 3/4 times 2 2/4. How many fourths are in 3/4? 4/4 plus 3/4 equals 7/4. And 2 2/4 is the same as 4/4 plus 4/4 plus 2/4, or 10/4. So 7/4 times 10/4. So if we're going to draw a picture, we'd have 7 by 10, and each of the squares is 1/4 times 1/4, which is the same as 1/16. So how many 1/16 pieces do we have? We have 70. 70 times 1/16 is 70/16. Or divide 70 by 16. Well, 16 times 5 is 80. So it's not 5. Let's try 4. 16 times 4 is 64. Subtract, we're left with 6. So 4 and 6/16. We can divide that by a factor of 2, and we get 4 and 3/8. So 70/16 or 4 and 3/8. Okay, number 5. So we have eighths and halves. I want to go ahead and turn them both into eighths. So I'm going to have 1 and 3/8 times 2 and 1/2. What do I have to multiply the halves by to get eighths? 4 over 4. So it's 1 and 3/8 times 2 and 4/8. Okay, let's turn these into fractions greater than 1. In one whole, there's 8/8 plus the 3/8 is 11/8 times 8/8 plus 8/8 plus 4/8. So 8 and 8 is 16 plus 4 more is 20. So 20/8. So our model for this one would be 20 by 11. And each square is 1/8 by 1/8, or 1/64. So each of the squares is 1/64. So 11 times 20 is 220 times 64. So 220 over 64. Or simplified, okay. It can't be 4 because 4 times 6 is 24. Let's try 3. 3 times 4 is 12. 6 times 3 is 18 plus 1 more is 19. Subtract. I'm going to be left with 28. Okay, there's no more numbers to bring down, so 3 and 28/64. Well, I know I can reduce at least by 2. So I get 3 and 14/32. I can reduce by 2 again, and I get 3 and 7/16. Now that's as simple as I can get because 7 is prime. So, or 3 and 7/16. All right, so now in our next one, number 6, we have 1 and 1/9 times 1 and 2/3. 1 and 1/9 times 1 and 2/3. Okay, I'm going to change this thirds into ninths by multiplying by 3 over 3. And so we have 1 and 6/9. All right, so how many ninths are in 1/9? Are in 1 and 1/9? 9/9 plus 1/9 is the same as 10/9 times 9/9 plus 6/9, or times 15/9. So 9 times 9 is 81, and 15 times 10 is 150. So in our model, we're multiplying 1/9 by 1/9 pieces. So each square has to be 1/81. We're going to have 10 by 15. Okay, so that basically means we have 150 times 1/81. We have 150 of these 1/81 tiles. So we have 150 over 81. Or, simplified, I can only get 181 from 150. And that's going to give me a remainder of 69. Well, 6 plus 9 is 15, which means it can be divided by 3. And 8 plus 1 is 9, which means it can be divided by 3. So let's simplify by 3. 69 divided by 3 is 23. And 81 divided by 3 is 27. So 150/81, or 1 and 23/27. Okay, number 7. Explain how finding the area of a rectangle with whole number side lengths compares to finding the area of a rectangle with fractional sides. Well, don't we multiply both by the size of the length and the width? Sure. So with whole numbers, I just multiply length times width. The process is going to be the same even with fractional size. Same process. Fractions or whole numbers. Length times width. All right, number 8. Terrence is designing a garden. He drew this diagram of his garden. Pose a problem using mixed numbers that can be used solving his diagram. So we have 3 of something this way, and we have 1, 2, 3, 4, 5, 6, 7 of something this way. Well, if they're 1/2 size pieces, could be 3 halves, right? I'd have 1/2, 1/2, 1/2. And 7 halves, I could have, so I could have 1/2 times 3/2. How did I get that? Well, 3 halves is the same as 1/2. 7 halves is the same as 3/2. So what could his problem be? Well, it could be, let's see, something like this. Terrence's garden is 1/2 yards by 3/2 yards. What is the area of Terrence's garden? Okay, how many halves are in 1/2? It would be 2/2 plus 1/2, which is 3 halves, times 3/2 would be 2 halves plus 2 halves plus 2 halves plus 1/2. So 2, 4, 6, 7 halves. And that's what we see. We see 3 times 7. So each of the pieces would be 1/2 times 1/2, or 1/4. So the area of each square is 1/4. So he has 21/4, or 5 1/4 square yards. Number 9, Tucker's bedroom is a rectangle that measures 3 1/3 yards by 4.5 yards. His dad buys 2 area rugs that each has a length of 4 yards. One rug has an area of 16 square yards. The other is 12 square yards, which will fit Tucker's room. All right, so we have 3 1/3 times 4.5. Well, I want to go ahead and make the denominator is the same just to make it easier for finding the area. And so 2 and 3, well, that can become 6, right? So I'm going to multiply 1/3 by 2 over 2, and that's going to give me 3 and 2/6. And then I'm going to multiply the 4.5 by 3/3, and that's going to give me 4 and 3/6. All right, now, how many sixths are in 3 holes? 6/6 plus 6/6 plus 6/6 plus the extra 2/6. 6, 12, 18, 20 sixths is the same as 3 and 2/6 times, well, 4 would mean I'd have one extra set of 6/6 plus the 3/6. So 4 times 6 is 24, plus 3 more is 27. All right, so we have a 20 by 27, and each square is 1/36 of a square yard. Okay, because 1/6 times 1/6. All right, so now what do we have? We have 27 times 20. We have 540 1/6 pieces. 540 1/6 pieces. So we have 540 over 6. 540 sorry, 36ths. Right? We said 1/6 times 1/6 is 36. So 540 divided by 36, not by 6. So in our problem, 27 times 20 is 540, and each of the area of each of the squares is 1/36. So how many of those do we need then? Well, 54 take away 36 is 18. Bring down the 0, and that should be 5. 5 times 6 is 30. 5 times 3 is 15, plus 3 more. Yes. So 15. So we have 15 square yards. Tucker's room is 15 square yards. He can only use the 12 square yard rug. The 16 square yard rug is too big. Okay. $540 times 1 divided by 36 equals 15 square yards. Right, and number 10. Nancy's garden has the dimensions shown. She needs to find the area of the garden so she knows how much topsoil to buy. Complete the area model. All right. So we know that the sides are 4. The top and bottom are 4 plus 1/2. And the sides are 3 plus 3/4. Well, I can do 3 times 4. Okay, 3 times 4. And I can do 3 times 1/2. And on the bottom, this bottom section here would be 3/4 times 4. And this little small piece here is 3/4 times 1/2. All right, well, 3 times 4, that's 12. And 3/4 times 4 is the same as saying 3/4 times 4 over 1. So 12/4, which equals 3. And 3/4 times 1/2 is 3/8. And 3 over 1 times 1/2 is 3 halves. All right, so we have 12 plus 3 plus 3 halves plus 3 eighths. Well, let's multiply this by 4 to get eighths. And 12 eighths plus 3 eighths is 15 eighths, which is the same as 1 and 7 eighths. So 12 plus 3 is 15, plus the 7 eighths, plus the 1 and 7 eighths, 16 and 7 eighths square yards. All right, so that's it for our lesson on area and mixed numbers. So until next time, I will see you soon.